Okay, my goal for today is for you guys to be able to solve equations by adding or subtracting. So if you add or subtract the same number to both sides of an equation, then the two sides remain equal. For example, if I have 4x equals 4x, okay, if I just add 7 to both sides, 4x plus 7 is still going to be equal now to 4x plus 7. Whatever I do on one side of the equal sign, I have to do to the other. So I added 7 on this side. I must also add 7 on this side of the equal sign. When you have equations with the same solution, they are called equivalent equations. As you can see, everything over here is the exact same as over here. So these are equivalent equations. And both of these words have EQU in them. Equal, equivalent equations. They're equal on both sides. Okay, let's see here. Let's go to the next page. We can use this idea of whatever we do to one side to the other, we have to do also to the other side as a means of isolating a variable. So I want to solve for x. I have x minus 3 equals 6. My goal is to get x all by itself. I want x to be equal to just some number. So what I would do first is I know that I have to get rid of this minus 3. In order to get rid of this minus 3, what I want to do is add 3 to both sides. Now, the reason I would add 3, if you think about it, negative 3 plus 3 is 0. So I got rid of it. Well, we have to remember, whatever we do to one side of the equal sign, I have to also do to the other. So since I added 3 over here, I must also add 3 on this side. 6 plus 3 is 9. So x equals 9. And we can plug it back in and check. Is 9 take away 3 actually 6? 9 minus 3 is 6, so it works. So x is equal to 9. Let's try another one. If I have x plus 1 equals 10, okay, I want to get x all by itself. It's being increased by 1, or 1 is being added to my value of x. So to get rid of this value, what I want to do, I know if I have a positive 1, to get rid of it, I just subtract 1. I'm doing the inverse operation. It says plus 1, so I minus 1. Well, once again, whatever I do on one side of the equal sign, in order for it to be equivalent, to remain equal, I must also do it to the other side of the equal sign. So, I have x left. I just brought it straight down. 1 take away 1 is 0, so this is gone. I don't want to write anything. And then I've got 10 take away 1, which is just 9. So, once again, x equals 9. Let's try another one. Let's say I have q minus 14 equals 12. Okay, remember, I want to get rid of the number there. I want the variable all by itself. So since it's q take away 14, to get rid of that minus 14, I know that I'm going to have to add 14. In order for my equation to remain true, both sides to remain equal, I have to add the same thing to both sides. So I'm going to add 14 over on this side of the equal sign. So I have q here, then plus 0, we don't need to write that, equals 12 plus 14, we know, is 26. So we added 14 to both sides, which got rid of it on the one side, moved it to the other, and it remained equal. So my goal is always to isolate the variable. I want to get it all by itself. So if I have x plus a negative 3 equals 12. Okay? I want to get rid of this negative 3. I want to get x all by itself. So since it's a negative 3, to get it to be 0, I want to have a positive 3. That's a little bit confusing because we have plus and negative. But I just ignore this plus sign for just a second here and just focus on the -3. How do I get -3 to be to 0? Well, if I add 3 to -3, then it's 0. So whatever I do on one side of the equal sign, I have to also do to the other side. So 12 plus 3 is 15. So I have x equals 15. Okay, try another example. 20, oh, you know what? We forgot to go back and check our work. Let's do that real quick. So if I have 15 plus a -3 equals 12. Let's think back to our song. It says, same sign, add and keep, different signs subtract. So these have different signs. So 15 minus 3 we know is 12. Then keep the sign of the larger number. Well, the larger number is 15. So 12 equals 12. That one's true. Okay, let's go back to this one. 26, take away 14. 26 minus 14 is, in fact, 12. So that one worked. Always want to check your answers just to make sure you didn't make a simple little mistake somewhere. Okay, I'm going to give you 3 problems, and I want you to pause the video and take a second to try these on your own. A minus 4 equals -9. -12.3 equals P minus 4. And the third one, -4.8 plus y equals a -13.7. Like I said, pause the video and give yourself a second to try these. Okay, if I were going to do this problem myself, I would look at the first one. I have a minus 4 equals -9. I know I want to get a all by itself. So I've got to do the inverse operation of subtracting 4 to get it to 0. So the opposite of subtracting 4 would be adding 4. I know -4 plus 4 is going to be 0. I also know whatever I do on one side of the equal sign, I must also do to the other. So I end up with -9 plus 4. Okay, so -9 plus 4. They're different signs, so think back to the song. Same sign, add and keep, different signs subtract, then keep the sign of the larger number. So 9 take away 4 is 5. The bigger number is negative, so keep the sign of the larger number, then it will be exact. -5 minus 4 is in fact -9. So my answer for A, for 1, A is equal to -5. For number 2, I want to get P all by itself. So once again, I have -4. So the inverse operation is going to be 2 plus 4 is 0. So I'm going to add 4 over here. As I was saying, same sign, add and keep, different signs I'm going to subtract. So 12.3 minus 4, I know, is 8.3. Keep the sign of the larger number, then it will be exact. So it's -8.3 is equal to P. Once again, I would plug that back in and check. -8.3 minus 4. Well, we know since we're subtracting that we just add them and keep that same sign. So -8 plus a -4 is -12.3. That is correct. Okay. So now for the very last one, I want to get y all by itself. I have a -4.8. So to get rid of that -4.8, I'm going to add 4.8 to both sides because a -4.8 plus 4.8 is 0. So that's gone. I'm just left with y equals, these are different signs. So I know I'm going to subtract and keep the sign of the larger number. So I know my answer is going to be a negative. So this time I have 13.7 minus 4.8. Okay, I'm going to borrow. 17 minus 8 is what? 9. 12 minus 4 is 8. So my answer is a -8.9. Plug it back in and check. -8.9 plus a -4.8. I would just add those together. 9 plus 8 is 17. Carry my 1. 8 and 4 is 12. Plus 1 more is 13. Bring down my decimal point. And they're both negative, so it'd be a negative 13.7. So that is correct. So my answer was negative 5 for A, negative 8.3 for P, and negative 8.9 for Y. Okay, this problem is very similar to the ones that we've been doing, except for this time the number that we need to get rid of is a positive. I've got a positive 9 plus A equals negative 3. So in order to get rid of 9, I know if I have $9 and I spend $9, then I don't have any. So if I have 9, to get rid of 9, I'm going to subtract it. Whatever I do on one side of the equal sign, I have to do to the other. So 9 take away 9, that's gone. That's just 0. So I'm left with A, which is perfect. That's what we want, A all by itself. Negative 9, or negative 3 minus 9. I could think of this as negative 3 plus a negative 9, or if you want to think of it as subtract, negative 3 minus 9. Change the minus to a plus, change the sign of the next. Then all you do is add them up as if it were a plus. So 9 plus 3, we know is 12. They're same sign, so I keep that same sign. So my answer is negative 12. Let's try another one. Let's throw a fraction in here, mix it up a bit. So I have 5/6 is equal to y minus negative 2/3. Now let's think back to what we said about subtracting. Change the minus to a plus, change the sign of the next, then all you do is add them up as if it were a plus. So if I have a double negative is always equal to a positive. So this was the same thing as having 5/6 equals y plus 2/3. Okay? In order to get y by itself, I've got to subtract 2/3 from both sides of my equation. 5/6 minus 2/3. This poses a problem. Over here I'm good. They have the same denominator. I can get rid of them. 2/3 take away 2/3 is 0. So I have y over here. But now on this side of the equation, this isn't a very nice fraction. Now if you have a calculator, this would be easy to do. But we're smart enough that we don't need calculators. So we're going to do this ourselves. In order to be able to subtract fractions, remember, they have to have common denominators. That's common bottom numbers. This one's a 6, this one's a 3. They're not the same. But I know that I can easily change 3 to 6 if I just times it by 2. Well, just like in an equation, whatever we do to one side, we have to do to the other. We know with fractions, the same thing. Whatever we do to the bottom, we have to do to the top in order for it to remain equal. Because if you think about it, 2/2 is just the same as multiplying it by 1. Anything multiplied by 1 is just itself. So I have 5/6 minus 4/6. Now I can easily subtract that. We know that's 1/6. So my answer, y is equal to 1/6. That was kind of a lot to take in. Let me backtrack for just a second. Let's look at common denominators. 5/6 and 2/3. Okay, I wanted the bottom to be equal to 6. So I asked myself, what do I times 3 by to make it equal 6? Well, that's 2. Well, I can't just times the bottom by 2 and not the top. Whatever I do to the bottom, I have to also do to the top. Because like I said, 2/2, you know, 2/2 is just 1. If I do 2/3 times 1, that's just 2/3. Well, doing 2/3 times 2/2, it's still multiplying it by 1, but it's just changing it. Well, we know that 4/6 is the same as 2/3, so that's why when I multiplied it by this form of 1, I still have the same thing as 2/3. 2/3 and 4/6 are equivalent. They're equal. They're the same. This one's just reduced, and this one is not yet reduced. But I don't want it in a reduced format because this one has a 6 on the bottom, and I want to be able to subtract it. So that's why we changed it to 4 over 6. So 5 minus 4 we know is 1. The denominator stays the same. So 5/6 minus 4/6 was 1/6. Okay, we'll give you a few to try, and then I'll post the answers. So you're going to want to write these down, then pause the video. H plus 8.5 equals 3.4. Solve for H. Second one, -3 is equal to G plus 2.5. Solve for G. And number 3, -2/3 is equal to B minus a -1/3. Remember your rules. Change the minus to a plus, change the sign of the next, then all you do is add them up as if they were a plus. Okay, pause the video and go ahead and try to solve these 3. Okay, I'm going to go ahead and give you the answers. Hopefully you tried these. H is equal to -5.1. There's a point in there. It doesn't look like it. Okay. And G is equal to -5.5. And B is equal to -1. Remember on this one, change it to a positive. Then you subtract 1/3. So 2/3 minus 1/3. Lucky for you, they already have common denominators. I know since they're the same sign, I just add them and keep that sign. So that's 3 over 3, and it's negative. -3 over 3 is the same as -1. All right, that's all that I have for you for today. Check progress book for your assignment, or go ahead and just write this down. It's page 132. Page 132, numbers 15 through 25, all. Now, the odd answers are in the back of the book, but you have to show your work in order to receive full credit. So make sure that you are showing your work, and you will not get credit if you don't show your work. So anyway, make sure you show your work. Page 132, numbers 15 through 25 all. And I do highly recommend checking your answers. That way, as you're working, you can see if you're doing this correctly. If you are doing it correctly, then, don't worry about the even answers. I'll give those to you in class. If you're not getting the same answer in the back as in the back of the book, then you must be making a mistake somewhere. So look back over your notes and see what you're doing wrong.